Hello everyone, or I guess just Robert. Welcome to Call the Doctor. I'm Matt Larson, and today I'll be talking about the REST vol. So I'll start off with, in case you're not familiar at all, I'll go over what the vol is, what a vol connector is. Then I'll compare the REST vol to some other options for working with HDF5 in the cloud. And then towards the end, I'll go over some new features in the REST vol and talk a little bit about future plans. So to start off with, in case you're not too familiar with the internals of the library, what is the vol connector and what is the vol layer? Vol just stands for virtual object layer, and it's a layer in the library that sits between the external API that faces the user and how storage is implemented. And so, depending on which vol connector you're using, your HDF5 files that you create and write to might be stored in your local file system if you're using the default native vol. They might go to an S3 bucket, might go to an instance of an HSDS server, or something else entirely. Users can develop their own vol connectors and use them without any intervention from the HDF group. And so the vol layer serves as a good way to increase the flexibility and extensibility of the library. The REST vol in particular is a vol connector that maps API calls, which create files and other objects, to REST requests that get sent to an external server. Typically, this is going to be an HSDS instance, and I'll talk about HSDS in a minute, but in principle, you could go write your own server that handles these requests and implements storage somehow. To give a bit of background, this REST vol was initially developed back in 2017, and it was developed for a few years for HDF5 1.12. That was the iteration library where the vol layer was first developed. But around 2020, development on it sort of languished and it fell behind the main library a bit. But now it's back in active development, working with the latest library versions and having new features added all the time. And the REST vol implements most of the core library's functionality. So any stuff you want to do with data sets, filters, selection IO, the odds are good that it supports it. This diagram here sort of illustrates the vol layer in a bit more detail than the last slide. You can see on top, your application works through the API, which passes through the vol layer, and then based on which vol connector is being used, changes how those storage operations work. So what is HSDS? It's essentially a way to work with HDF5 files on the cloud through a REST API. What's interesting about HSDS is that it doesn't have a fixed storage option or a fixed deployment option. You can use HSDS with a backend of an S3 bucket or an Azure blob or even your local file system. Similarly, there are a lot of different ways to work with files that you have stored through HSDS. You can use the Python module h5pyd. You can use a set of command line tools called the HS tools, or most relevantly for right now, you can use the REST vol. This diagram at the bottom shows a little bit of HSDS's architecture, and the important thing here is to notice that it uses multiple service nodes and multiple data nodes to handle requests made by clients. So how does using the REST vol with HSDS actually compare to whatever other options exist to work with HDF in the cloud? Well, if you still want to keep working with C, then you could use the ROS3 VFD. ROS3 stands for read-only S3. VFD is virtual file driver. You can think of virtual file drivers as being similar to the vol layer in that they serve to change how storage operations are done while keeping the external API the same. So as you might expect from its name, the read-only S3 VFD is read-only, and it only works with S3 buckets. So it does limit your options compared to using the REST vol with HSDS, but it could work for some use cases. Alternatively, on the Python side, you have that h5pyd module, which can work with HSDS itself. And so if you think you might want to work with HSDS, but you aren't too strongly attached to working in C or working in Python, how might you actually decide what you want to use. Are there any feature differences? And there are. The RESTful supports some things that H5PyD does not. One of which is multi-read and multi-write. Multi-read and multi-write are a new API call that was added in HDF5 1.14. And it bundles up requests to read and write from multiple data sets at the same time. It gives the underlying implementation of the I/O a chance to do optimizations with that information. And you'll recall earlier I mentioned that HSDS has these multiple data nodes and multiple service nodes which handle requests. And so when the RESTful gets this information, this request to read from multiple data sets or write to multiple data sets, it can take advantage of that architecture and actually asynchronously send out each read request to a single data set as its own curl request. And this takes advantage of HSDS's capacity to do work in parallel. Without this multi-read and multi-write, if you want to read from, say, 20 data sets, you have to assemble the request, send it off, wait for HSDS to do the work on just that one data set, and then send it back. And only then can you begin the next request. So how impactful is this multi-read and multi-write on performance? Well, we have a benchmark based on an actual use case, which does reads and writes to, I think it's about 6 different data sets for a total of a few gigabytes of data transfer. And you can see here how a few different options for working in the cloud compare. You see the S3 VFD was the slowest at about 75 seconds. And then just as a baseline, the RESTful was a bit slower than H5PyD by about 10 seconds. But with some small changes to your code to take advantage of this bundled information with read and write multi, it cuts off nearly half the time. You can see that when using the multi interface, it took just over 30 seconds. So if you take advantage of all the features it has to offer, the RESTful is one of the fastest ways to work with HDF5 data in the cloud right now. And then this slide is, if you were at Hug or eHug this year, then you probably knew everything I just told you because I gave a very similar presentation then. But since then, and since the RESTful has been back in development, there have also been some other new features besides just read and write multi. Here are a few of them. One is support for fill values. Another is fast symbolic link traversal. And what that means is that HDF5's link structure supports, having a whole complex chain of links before it actually reaches a real object at the end. And before, if you wanted to access an object at the end of such a big link chain, every single link traversal would involve going back and forth to the server, opening a link, going back to the server to see what it points to, getting a link back, and so on. And so you could have you could end up going back and forth between your application and server many times before reaching an object. But now, all of that link traversal is handled on the server side, which speeds up some operations by quite a bit. There's also support for using fixed length UTF-8 strings as a data type in attributes and data sets. And then also, recently, the RESTful has been changed to support some limited compatibility with H5Py. H5Py is, again, in Python. It's one of the most common ways that people actually use HDF5. It provides a sort of Pythonic interface to it. This is still in a sort of experimental stage, so I wouldn't recommend using it for production purposes, but it's very exciting that these two pieces of software can work together. Also on the right here, I have this big list of just some miscellaneous API functions that are now supported in the RESTful, so they're sort of smaller features, but it's still getting that more complete API coverage. As far as some things which are still sort of in the pipeline and in progress for the RESTful, which you might expect to see soon, there's numeric type conversion, handled automatically. So say, for example, if you have a data type if you have a data set or attribute with floats, but you want to read or write to it in the form of integers, soon the RESTful will be able to handle that case automatically, just like the main library. And also coming soon is support for connecting to multiple servers. with just one instance of the vol. So then you could, for example, say open 3 files, each of which is on a different HSDS instance, or even just different servers that you've written and spun up yourself. So that's pretty exciting. That's all I have. Be happy to take any questions or go over anything that anyone wants to hear more about.
Matt, I had a question. I think it was back on slide 4, maybe. I'm not 100% certain of that. Yes, right there. Just from my, I want to double check this. I think the answer is yes, but I'm not 100% certain. If I have a C end user application, I can dynamically load multiple distinct REST vols as well as a ROS3 native vol simultaneously. There's no issues with that. I can, as long as I have the correct paths and everything of that sort, I can hold different vols in memory at the same time. There's no conflicts.
Yes, I believe that's right. If you're dynamically loading it, then there were originally some slides about this, which I cut out for time, but it seems to me I should have left them in. They'd be useful here. But if you're dynamically loading a vol, then sort of by default, the property lists, like for example, the file access property list is going to be one that corresponds to using the REST vol. And you need to manually go in and change it to have an operation go to, say, the local file system through the native vol. But yes, you're right that you can have REST vol operations and native vol operations going on side by side by working with the property lists.
Okay. Okay. So just in terms of sort of a simple use case, if I were copying, let's say, from a data store that was handled by one particular REST vol, but I wanted to take it to another one that's a completely different REST vol, I could do that fairly. Maybe a little bit of bookkeeping on the application end, but such a copy operation could hold those 2 REST vols in memory at the same time.
I don't believe it's possible to load multiple instances of the same vol connector.
No, I mean different ones. No, different ones. No, this would be if data store A was handled by a particular REST vol and data store B, that let's say the one that I was writing to was handled by a completely different REST vol, I can make that happen on the C end. On my application end, I wouldn't want to load the same REST vol. These would be two distinct REST vols.
I see. So if I understand right,
well,
you're talking
okay,
about a scenario where you might.
Oh, maybe that's a bad example. Let's say one custom vol. I'll generalize it. Let's say it's one custom vol to another custom vol.
Mm-hmm.
I can dynamically load both those at one time and say copy the contents from one into the other or a selected portion of it.
Mm-hmm.
Okay. I just wanted to make certain that that's doable.
Yes, I believe so, because say the first custom connector would read from however its own storage is implemented, read that just into a buffer in memory, which should then be able to be written to in another operation to whichever other vol connector is implementing its own storage, because it goes from the first data store to an in-memory buffer, then to the second memory store. So yes, that should work fine.
Okay.
The only sort of caveat there is you mentioned dynamically loading 2 vol connectors, which just because dynamically loading uses environment variables, which can only have one particular value, I think you would need to manually link at least one of them to do that. But besides that, yes, that should be possible.
Okay. Okay. Yes, I haven't looked at the environment variable usage there in the dynamic loading circumstance. Okay, well, this was just sort of a high level. I wanted to understand it a little bit better. Thank you.
Thanks for asking.
Mm. Okay.
All right. Well, thank you, Matt, so much for jumping in and,
Yes,
and
thanks, Matt.
taking this session. We really appreciate it. Next week, as far as I know, we have Alexander scheduled unless he finds a substitute or tells me he needs a substitute. So we'll see you all back again next week.
Thanks for listening.
Okay, thanks, Matt.
Thanks. Bye, everyone.